that thing in the movies where they go, action! You're the sound check. All right. That being said, let us move on, cabbages. If I were, go away. If you were to see that, are those factors or a product? Factors. Why do you know they're factors? Because it is this binomial multiplying this binomial, yeah? Okay. So what would the answer be? X squared plus 10x plus 24. Now, why were you all able to do that so quickly? Because of the little shortcut that works when?
When it's x.
When it's just a single variable, right? Now, since you all knew that shortcut, let's pretend that you don't. You had to FOIL this, right? So if you were FOILing this, you would have x squared plus 6x, yes? And then you would have 4x plus 24, yeah? And then, of course, you would collect your like terms, x squared, and then 6 plus 4. Hey, wait a minute, 6 and 4. 6 plus 4, 10x. 24, 6 times 4, 24. Hey, wait a minute. And you'd all figure out the shortcut on your own, yes? Okay, that's expansion. We are going to work on going backwards. So how did you know what this was right away? You knew that you were going to add that and that to get the green term, right? And then you knew that that was adding them and this was multiplying them, correct? So if I wanted to go backwards and I have something that is already in trinomial form, I know that to factor that, I'm going to need two x's to make x squared, and I'm going to need two numbers that will do two things. Those two things are what? Multiply to 24 and add to 10, right? Now, if two numbers are going to multiply to 24, they must be factors of 24, yes? So what you have to do to yourself, at the beginning, you're going to need to do this more than you will as you practice. Remember, in factoring, we're looking for not prime factors, we're looking for pairs of factors. So for 24, it's 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Now you look at that and you say, what pairs there can make 10 in any way? And you should say to yourself, well, 12 minus 2 will make 10, and 4 plus 6 will make 10. So now I have to think, since I have to multiply to a positive, I can't do 12 minus 2, can I? Because that would throw a negative in here. So it has to be 4 and 6. And then we write it out as x plus 4 and x plus 6. Now, do not feel that you have to write it x plus 4, x plus 6. You could write x plus 6, x plus 4. They are the exact same thing. The only time you have to be careful is your signs must work upon expansion. Okay? Now it seems a little weird, but when you do one or two of these, like, oh, that's it? That's what people are scared of when it comes to factoring? Because people are scared of factoring as you get higher and higher in math. It doesn't get much more difficult than this. So I look at this right here and I say to myself, what do I need? I need x and x, x and x, and I need two more numbers that are going to multiply to what? Look closer. Negative 18 and add to what? 7. So what are the factors of 18 that will get me to 7 in any way? Kathleen, 2 and 9. How will I get to positive 7 using 2 and 9? I know it's 2 and 9, but I need to have positive 7, so it's negative 2 and positive 9, yes? So that goes in the blank. -2, +9. And that's factoring. Tavleen. Yes, I know what you're asking. Yes. Tavleen is asking for this. Let's find some space here. X squared plus bx plus c. The answer is x. And since they're both positive, you've got I'm just doing it all with positives. You got to understand the signs, right? This guy right here I'm going to use m and n. And m plus n must equal b, and m times n must equal c. Something like that, Tavleen? Is that what you're looking for? Okay. Just like when we did the expansion of this, our answer became x squared plus m plus n x plus m times n. Just like that. It's the reverse of what you already know how to do. Everybody good? Now, it's very key that you guys understand how this gets to this. You have to understand expansion, right? Because you have to be aware when you're factoring, especially more complicated ones, that this number is always these two multiplied, right? So let's look at the next one, which looks similar but is slightly different. What must I multiply to? -8. And what must I add to? -2. So what is it? -4 and +2, right? So x minus 4, x plus 2. Now this unit really bothers math teachers for a couple of reasons. One, people hand in the answers wrong, which should be impossible, shouldn't it? Because once you write down an answer, how easy is it to check? Is -4 plus 2 -2? Is -4 times 2 -8? So is it right? So there's no reason to hand something in wrong, correct? Even if you screw up the signs somewhere along the way, when you expand it out, oh crap, that doesn't work. I can't possibly be right. Kind of like when you tell me that the hypotenuse is shorter than one of the legs. Now, you will notice that normally I don't spend a lot of time showing you a method without giving you a why, right? Factoring is one of those things that the why it works, you don't know it until you know the method. Do you understand what I'm saying? Until you see it re-expanded. Oh, that's weird. Why is that happening? And then you expand it like, oh, all right. Okay? All right. So this one here, what do I got to multiply to? 35. And what do I got to add to? -12. What is it? It's got to be -7 and -5. This is negative, this is positive. Because that's positive, I need two of the same sign. Because that's negative, they must both be negative. Everybody cool? You guys try D. Multiply to what? -20. Add to what? 12. What is it? Is it 1 and 20? Is it 2 and 10? It looks like it's 2 and 10, doesn't it? So let's do that. That's negative, so it must be a plus 2 and a minus 10, correct? And you'd hand that in. Except it's not, is it? Because what happens when you expand that? What's 2 minus 10? Negative 8. Oh, okay, Mr. Myers, you got me. It must be minus 2 plus 10. No, because what's that? Positive 8. So, does this factor? No. And that's the key here. That's why I put it at D. Just when you're getting comfortable, I put that there to watch you all go, there's got to be a plus 10, a minus 2. No. Oh, okay. A minus 10, a plus 2. Yeah, Mr. Myers, yeah, no. If it doesn't factor, it doesn't factor. That's why that question is there. Because sometimes they won't. Sometimes it's as simple as it gets. Does everybody understand what I am saying? Do not try to make a question fit to what you want it to. All right? That would be like trying to study, do a scientific experiment and saying, all right, I want this drink to have the best results. So I'm going to make sure that this drink wins. Understand? You can't do that. So this is a does not factor. And I put it there to mess with your heads. Now after that, we're back to normal. Everybody do E. This one you can do. So you go ahead and try E on your own. Multiply to what? Add to what? Please notice how much work I can do before I even have to think about it. Right? So what are the two numbers I need?
7 and 2.
7 and 2. Which goes where? Plus 2 minus 7, because I needed negative 5, right? All right. Is everybody cool with the basic workings of trinomial factor? We've done 5. They're all the same. Okay? The only time it gets slightly tricky, and I just want to show you one of these, is when it's this type of one. X squared minus 32x plus, I lie, minus 33. That one usually messes kids up. Why? There's no factors of 33 that make 32. What are the factors of 33 that make 32? 1 and 33. Kids always forget 1 and 33. Or 1 and whatever. Always. That's one that they always forget. Here's the other one they always forget. X squared plus 13x minus 30. What's weird about that one? Jenna says it's 10 and 3, is it? No. Why? 10 and 3 won't make 13. It's 15 and negative 2. Once you go past the 12 times table, you guys start screwing stuff up a bit. Okay? Those are the two big errors. They forget 1 and 33, and they forget that there's numbers past 12 that multiply. Okay? So, that's the basic stuff. Everyone's cool? All right, look at F and tell me what's different. There's a leading coefficient, yes? Have I taught you what to do with that? No. But have I taught you a way to get rid of those? What was the first kind of factoring I taught you? The one that I put a big star beside and said, always do this first. simplify with the greatest common factor, yes? What's the greatest common factor there? Hint, hint, it's the factor we want to get rid of. 4. So I divide everything by 4. Can I forget about 4? No, I have to rewrite this with GCF out there and the quotient in here. X squared minus 5x minus 14. Now, look at what I have done for you guys because I'm a nice guy. They're the same, right? That's because I added something new there and I didn't want to mess with your heads. So what do I do with this when I see something I can continue to factor? I factor again. And I get x plus 2, x minus 7. Is everybody good with that wrinkle? It's not new, because you've already done GCF, right? Okay. So look at G and tell me what you don't like. I don't like the 10. So now I need to check if I can get rid of it by dividing it out. Does 10 divide out of that? So I go ahead and I do that. I divide by 10 and I rewrite 10 x squared plus 8x plus 12. And then I check, can I factor this? If it factors, then I must have two numbers that multiply to 12 and add to 8. What are they? Plus 2, x plus 6. Gouda? Great. Did I tell you guys a story about the kid in my grade 9 class 5 years ago? We were doing factoring. Factoring used to be in grade 9. We were doing factoring. This kid was so bad at math. So bad. Like, embarrassingly bad at math. He was okay with it, but he was bad at math. Like, what's 3 plus 4, kid? You got me, Mr. Myers. That's a real poser. Like, come on, really? Let me get my calculator out. That type of level of math skill. We got to factoring, and he was like Rain Man. If you haven't seen that movie, that reference is completely lost on you. But he could look at this and tell you it was going to be 10, 6, and 2 before ever writing anything down. It was the weirdest thing. And then when that unit, I thought like, oh man, this is where maybe things are going to be okay. Next unit. What's 3 plus 4? I told you last unit I didn't know that. H is weird. Why? There's a negative 4. Now, what do I call that first type of factoring that I taught you? Greatest common factoring, yes? That's really a bad name for it. Everybody calls it greatest common factoring. Because what do I want to get rid of here? I only know how to factor when that t is by itself, correct? So what do I want to get rid of here? The negative 4. So even though negative 4 is not the greatest common factor, what's the greatest common factor here? Positive 4, isn't it? But because I still want to get rid of that negative, I'm going to divide everything by negative 4. And now what do I get? Positive t squared, what happens here? Plus 4t, and what happens here? Minus 32. And now, if that factors, there's two numbers that'll multiply to negative 32 and add to 4. What are they? Plus 8 and minus 4. Okay. Now you guys will notice that amongst your friends, when you are doing these questions, you will have friends that see the two numbers immediately. Much like Kathleen is doing right now. You see it immediately. And other people will take a little bit longer. But it's like everything, right? Some of you make that headshot on Call of Duty 12 as soon as you pick up your sniper rifle. And others of us are a little shaky hands, we miss a few times. Right? It's just talent, skill, whatever you want to call it. Okay? Don't feel bad if somebody can see the pair before you. All right? And by the same token, if you're working with someone and you see the pair, I know how frustrating it is to wait there while your partner figures it out. Because I sit here waiting for 30 of you sometimes. Right? And it feels long. It's not. It's like 5 seconds. But when I'm up here and I'm waiting for the answer to -7 minus 4, and I wait, 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 and then somebody says, yes! And then you're like, ooh. Right? It's a long time, but it's not really. So let the people, if you're working with them, give them a shot at it. So, what's weird about I? It's in a reverse order, right? So what are some options? What could I do here? I might be able to factor it right away, right? Or I could switch the order around. I need to have a -d squared, a -5d, and a -24, right? Now it's in the order I like. Do I have all the same stuff? Yeah. Am I allowed to do this? What do you think? Am I allowed to do it? Well, it looks just like this, right? So yeah, we are going to factor out the negative. I can do this because I have all the same things, yes? In my hands, I have an empty bottle, a remote, and a pen, yes? My magic pen. Now what's in my hands? Bottle, remote, pen. Now what's in my hand? Bottle, remote, pen. Does it matter? No. I still have a bottle, a remote, and a pen. Got it? So I can move stuff around however I see fit to make it look like whatever I want it to look like, as long as I keep all the same pieces. Would I be allowed to do this? Here's a bottle, remote, and a pen. No, why? Because it's not a remote, it's a calculator. Okay? Now you could be a dink, and you could go, bottle, remote, pen, because my cell phone is indeed my remote for my TV and everything. Because my stupid kids keep losing the remote. So I turn this into the remote for my TV and everything. Because I'm not going to lose my pen or my phone. They don't really lose the remote. It just gets buried in the couch. Or under the couch. Or in the doghouse. Or in the other room that has a TV, even though that remote doesn't control anything in that other room. Sometimes it's in my daughter's bedroom, which I don't get. She doesn't have a TV in there at all. I don't know what she's trying to control in her room with the remote control, but it's something. So anyway, Tavleen says we're going to take out the negative, which means what happens in here? D squared plus 5d plus 24. Can I factor that? It looks like you can, right? Why? You think 8 and 3. Can you do it? Can't, can you? So some people say, well, what about, Mr. Myers, what if I don't take out that negative? What if I leave it like this? Well, then it has to be -8 plus d, and then would have to be 3 minus d, right? Right? Does that work? -8 times 3 is -24. Okay. -8 times -d is positive 8d, yes? Plus 3d still doesn't work. Okay? This is another one where you can't be fooled. Okay? Just because it looks good doesn't mean it is good. Okay? All right, look at J and tell me what's different. What's different with J? There's a second letter, yes? Now, just like all math, if you know how to deal with it in one case, you know how to deal with it in every case? To deal with v squared, I must need v and v, yes? So what must I need to deal with b squared? B and B. And then does anything else change? Nope. But this is one of those ones that messes kids up. Why? Because it's 1 and 20. Right? 20 is only 4 and 5 and 2 and 10. Ah!
It's also 1 and 1.
Which one's positive? Plus 20b minus, how many b's? 1b. Do I write 1? No. Cool? All right, so you should be able to do k by yourself now. Because k is exactly the same as j. What makes k slightly difficult? What are the factors that I need? Two and 14. We're beyond the 12 times table, right? So it's 14. It's actually 14 and negative 2. Because I need 14 minus 2 to get 12. Right? Is that what you said? Or did you say negative 2 and 14? Oh, yeah, of course, negative 2 and 14, right. Now, what's weird about L? There's what? There's a 3. Damn! There's a cubed. Have we had any cubes? So what do we got to do? Go ahead, Tavleen. I'm going to take out a B. So what do I write out here? B, and what do I leave in there? A squared minus AB minus 20B squared. And then I just work it out. A, that's negative, so it's got to be plus 4B and A minus 5B. Is everybody good? That is all the wrinkles, the first level wrinkles of factoring trinomials. Is everybody cool with them? Max?
This L.
L, yes.
Since it's a squared minus ab minus 20b squared, would it matter how you would do it for ab? So could the answer technically be bracket a plus, let's say 10b, a minus, like, or would it have to be 4 and 5?
It has to be 4 and 5. Because when you expand it, 4 minus 5 gets me my negative 1. Right?
Oh, because is a and b 1?
Yes. Because there's no number there, right? Everybody cool? All right, that is all first level wrinkles. Look at M and see if you can figure it out. Because it looks different. Look at what you've already done and see if you can figure out what to do with x to the 4th. Look at the very question right above it. What did you do with x squared to get those two? The green ones, what did you do? You squared it, right? You took the square root of the first term, correct? Okay, so do you think that will work here? What is the square root of x to the 4th? X squared. Because x squared times x squared is x to the 4th, isn't it? Now, does this look normal for the rest of the way? What would I need to multiply to? 50. I haven't actually taught you this, but this is experimentation, right? So, all right, we notice something's different. We've done something that fixes that. So let's see what happens. We're going to multiply to 50 and add to what? Negative 15. What is it? Minus 5 minus 10. Now let's check. Negative 5 times negative 10 is positive 50, so we're okay there. Negative 10x squared, negative 5x squared. Hey, it worked for me. Do you see what I'm saying with this question, where I am going with it? Even though you had never seen it, I hadn't taught it to you, the mathematical tools that you have allowed you to solve the problem. All right, now, N, O, and P are special cases. They're special for a couple of reasons. Would we ever write that? No, we never would. It's there for teaching purposes. Here is what I mean. What would I really write that as? What should that trinomial be written as? Emma? Nope. Nothing. It would just be that. That's what it should be. I'm going to do something with that in about 2 minutes. Okay? But to get to this right here, I need you to understand what's going on here. So I leave the 0 in there because this looks like what you know, right? To do this question, you know I need to multiply to negative 9 and add to 0. So what is it? What are the factors of 9? 1 and 9 and 3 and 3, right? So x plus 3, x minus 3, correct? Minus 3, correct? 3 minus 3, 3 times 3, 9. Got it? Now, pay very close attention to that and that. And combine your attention with that to that and that and that and that. Do you see where I am going with it? Excellent. So all of you should be able to do O already. What is it? What did I do with the greens here? Yeah? How did you know it was 25? It's the square root of that, right? Now look at P. What's different about P from N and O? Everything in blue shares a characteristic. What is it? They're perfect squares. Everything in green shares a characteristic. What is it? Perfect square. So I know this is x, x. I know that's 4, 4. What's different in P? I heard somebody say it. What'd you say? There's an 8, right? How do I make those 4s get me 8? They're both adding. What if it was x squared minus 8x plus 16? Then what would it be? Still be 4 and 4, but they'd both be negative. Kathleen? Every time it's a perfect square on both ends, you can do either of these things depending on what it is. If there's no middle term, it's plus and minus. If there is a middle term, it's plus plus or minus minus. Yes?
So when we had x to the power of 4, like obviously we put this up with x to the power of 4.
Yeah?
Actually, no, go to the power, sorry.
Yep.
So x to the power of 4 minus 0x minus 25, so then we do all that, and then put that x, x here.
Yep. X squared minus 5, x squared plus 5. Oh, I thought you were doing a new question with 25 instead of 625. Because 25 works because it's squared as well. So yeah, there. Yep. Except you would do it again, which is what we're about to do. That's our very next page. Turn your page over 2 pages. No, I told you there's another part with a calculator. I looked you in the face and I said, this part is no calculator. When you're done, you give it back and you get this part. Don't worry, you can do it in a minute. So you guys need to turn your pages over to, I want to say 156. Is it 156? That says difference of squares?
Yeah, 156.
My personal favorite font, Cocktail Bubbly. I'm a big fan of Cocktail Bubbly. The font. The font. All right, so this is what we just talked about, yes? And that's why I like to bump these two into each other without giving you practice time in the middle, because they're so closely related. If you were to expand this, what would you have? X squared plus 4x minus 4x minus 16, yes? And what would happen right there? Cancel out, and you end up with x squared minus 16. Looking at that, you see perfect square and perfect square. I forgot the R. It's a perfect square and a perfect square. And you should notice that when you factor it, you take the square root of the first one, x and x. Then you take the square root of the second one, 4 and 4, and you put plus and minus between them. Everybody got that? 2 of you. What? Only works if it is a difference of squares. Because what happens if it was addition? You get that middle term. It won't drop out, which is letter P on the last page. Yep. We're going to do that right now. You're going to see it right now. So here's the shortcut, okay? Remember, I can't forget my other factorings, right? I still got to remember GCF and trinomial just in case. But the first thing, all you got to do is this. If it is anything squared minus anything squared, when you factor it, it is always the square root of whatever that is plus the square root of whatever that is, and then you do it again with a minus. Everybody understand? So let's look at this very first one, because this very first one is actually crazy tricky. People screw it up all the time. How do I know this is a perfect square? What is the hint in exponents that allows you to square root an exponent? How did you know the square root of x squared was x? Why do you know that? Okay, how do you know the square root of 4 is 2? Because 2 times 2 is 4. So how do you know the square root of x squared is x? Because x times x is x squared. So what must be the square root of x to the 4th? X squared. Why? Because x squared times x squared is x to the 2 plus 2, which is x to the 4th. So now, what's the hint? How do you know that that's a perfect square and that's a perfect square? What's the square root of x to the 6th? I'll remind you again. X squared, x times x. X fourth, x squared times x squared. So what would x to the 6th be? X cubed times x cubed. 3 plus 3 is 6. What's the square root of x to the 8th? X4, x4. So I'll ask again. What is it about an exponent that makes you know you can get a square root out of it? Did all of these have square roots? Yes. Did they all have exponents? Yes. What is the common characteristic between all of those exponents? They're what? Even. Can I get the square root of x cubed? No, why? Because x squared times x isn't the same thing. So, let's go back to where we were. Do I know the square root of x to the 16th? What is it? No. X to the 8th. Right? So, square root of that one, x to the 8th, square root of that one. What's the square root of 1? It's not a trick question. What's the square root of 1? 1. X to the 8th plus 1, x to the 8th minus 1. Am I done? Why? Are those both squares? Is that a subtraction between them? So I must continue. Can I forget about this guy? No. x8 plus 1, and this is now going to be what? x4 plus 1, and then what? x4 minus 1. Am I done? Why? Is that a perfect square? Is that a perfect square? So I got to keep going. Can I forget about the first two? x8 plus 1, x4 plus 1. What does this one become? X squared plus 1 and x squared minus 1. Am I done? Why? Because it's another set of squares. X plus 1, x minus 1. Now am I done? Yes. Now I showed you this one first, even though it seems complicated, because it shows you the pattern that works a million times in the same question. And it always works. Have a look at 2. What's different? There's 2 variables. Are they both perfect squares? Is this minus? Is 225 a perfect square? So can I do this? What's the square root of x squared y squared? xy. Plus, what's the square root of 225? 15. Then, xy minus 15. Does it work? X times x is x squared, y times y is y squared. 15 times 15, negative 225. Gotcha. Now, look at 3 and see if you can figure it out. What's it going to be? Z4 plus 12 and Z4 minus 12. And I'm done, right? Why am I done? 12's not a perfect square. It looks good, perfect square, minus, and then because if you haven't been paying attention to what we're doing and you've only been listening a little bit, even numbers mean something. That must factor. Doesn't. This is not a perfect square. Okay? Now, look at 4. 4 is the second hardest one of these kind we can do. What makes it difficult? There's coefficients. and variables. But is that a perfect square? 4. Yeah. Is x to the 6th a perfect square? Yeah. Is it minus? Yeah. Is 25 a perfect square? Yeah. Is y squared a perfect square? Yeah. So I can do this. What is the square root of 4x to the 6th? 2x cubed. Plus, what is the square root of 25y squared? 5y. And then I just do it again. Everybody good? And this gets no more complicated. Well, there's one thing that's more complicated I haven't taught you yet, and I'm not going to today. You are going to go back, and you, ladies and gentle people, are going to work on 154 and 155. On 155, 8, 9, and 10 are especially stinky. I haven't taught you the trick that I use to do those. I want to see what happens when you try 8, 9, and 10 on 155. Everybody good? So you are working right now on page 154 to 155. Tomorrow, we are going to have a factoring quiz only on easy stuff. Okay? Only on easy stuff. I've made it up. Don't look. Nobody look. Everybody look away. Look away. The quiz is not here under the big black binder. It is not this quiz in my left hand. Look away! I'm hiding it. Ta-da! See how I did that? I misdirected. I told you to look away and you all looked away. What? Hey, hold up. What? I just looked at it. There is some difference of square stuff, and there's a couple on there that will be graded accordingly. They are extremely challenging to see if you can do it. They'll be out of like 1. And of course, what will I do tonight? Put up the key to 154 and 155, including the trick to 8, 9, and 10 if you can't figure it out. Huh? I'll do my best to mark your tests. I can make no guarantees. Your quests. Yes. Emma. Oh, sorry. Tavlene had a question about the very first one. What? All right.